Now we are going to solve problems related to the objective immersed inclined, that is make an angle theta with the free surface, right? Please note down the problem. A rectangular plane surface 2 meters wide and 3 meters deep lies in a water in such a way that its plane makes an angle of 30 degrees with the free surface of water. Determine the total pressure. Determine the total pressure and the position of center of pressure and the position of center of pressure when the upper edge is 1.5 meters below the free surface, 1.5 meters below the free water surface, right? This is the rectangular piece, rectangular objective. The depth is given, that is 3 meters, and the width is given, that is 2 meters, right? The upper edge is 1.5 meters from the free surface. 1.5 meters from the free surface, right? This is the given data. Based on this data, we are going to determine the total pressure and center of pressure. We know total pressure formula. Cp is equal to rho g a h bar. Rho equal to, because this is the water, 1000 kg per meter cube. G equal to 9.81. A is the area, that is 2 into 3 h bar. First we are going to determine the h bar. H bar means the distance between the center of the object to the free surface. This is the center of the object. This is nothing but h bar. H bar is the distance between the center of the object to the free surface. But in the problem, they have given the top edge of this rectangular piece is 1.5 meters from the free surface of water. Now, h bar means 1.5 plus this distance. Say this is x. Okay. Now this is, say, x. This is, we know, because this is the top edge, this is the center. The total depth of the object is 3 meters. Therefore, this is 1.5 meters. This is also 1.5 meters. Therefore, this value is equal to 1.5 meters. I am going to draw the same diagram here. This is x. This is 1.5 meters. Because this is theta, automatically this is also theta. Now we are going to determine the distance x. This is from this point to this point. Now take the sine theta. Sine theta equal to opposite side x divided by hypotenuse 1.5. Therefore x is equal to 1.5 into sin theta. But in this problem they have given this rectangle object makes an angle, the angle is given, that is 30 degrees, theta equal to 30 degrees. Therefore 1.5 into sin 30, right? Now this is the x value. Now we are going to determine the h bar. H bar is equal to 1.5 plus x. This is the x. This is equal to 1.5 plus x is nothing but 1.5 into sin theta. 1.5 into theta is 30 degrees. Therefore h bar is equal to, from this equation we have h bar is equal to 2.25 meters. Right? Once we know the h bar, now we are going to determine the total pressure. P equal to rho, that is 1000 into g value 9.81 into area, that is 2 into 3 into h bar is 2.25 meters. Finally the total pressure or pressure force equal to 132.435 newtons or 132.435 kilonewtons. This is the total pressure. Now we are going to determine the center of pressure. Center of pressure formula Cp is equal to ICG into sin square theta by AH bar plus H bar. This is the formula for the determination of total pressure or H star. Center of pressure or H star is equal to ICG into sin square theta by AH bar plus H bar. Already I have derived in the last class this derivation. Now we are going to substitute the values here. First we are going to determine ICG. What is the ICG value? ICG equal to, that is the moment of inertia about the centroid, that is equal to B 2 into 3 cube BD cube by 12. This is the ICG. Theta value known to us, area known to us, H bar is also known to us. Therefore center of pressure equal to 2 into 3 cube divided by 12 into sine. What is the theta value? Theta equal to 30 degrees divided by area, that is 2 meters into 3 meters. 2 into 3 into H bar. Already we have determined, that is 2.25 plus H bar. H bar is nothing but 2.25. Therefore center of pressure or H star is equal to 2.333 meters. Right? This is the center of pressure. In this problem also the H bar is 2.25 meters, but H star should be lies below the H bar. Therefore this is the H star, that is the center of pressure, that is equal to 2.333. H star equal to 2.333 meters. H bar is equal to only 2.25 meters. Therefore the center of pressure lies below the H bar, that is the distance between the center of the object to the free surface. Right? Now we are going to solve one more problem. Please note down. a circular plate, a circular plate 3 meters diameter is immersed in water in such a way that its greatest and least depths below the free surface are 4 meters and 1.5 meters respectively. Right? This is the free surface of water. The greatest the diameter of the pipe is given. The diameter of the pipe is given, that is 3 meters. Okay. Right. This is the top edge, this is the lowest edge. What they have given here, immersed in such a way that its greatest and least depths below the free surface are 4 meters and 1.5 meter. That means this is 4 meters, this is 1.5 meter. Determine the total pressure on the face of the plate and position of center of pressure. What is the center of pressure? Total pressure formula equal to rho G A H bar. Rho equal to 1000 kg per meter cube, G is 9.81, A is the pi d square by 4 diameter given here. H bar we are going to determine first. Here they have not given theta value here. Now we are going to determine the first H bar. This is H bar, that is the center line, that is the distance between the center of the circle to the free surface. Now this is 1.5 meters, this is say x. X plus 1.5 is the H bar, right? H bar is equal to 1.5 plus x. Now we are going to determine x. Same diagram I am going to draw here. Theta is unknown, theta is not given. This is x. This is equal to, because this is 1.5 meters, this is 1.5 meters, so that this value is 1.5 meter. 1.5 meter. Now we are going to calculate take sin theta. Sin theta equal to opposite side x divided by hypotenuse, that is equal to 1.5. Therefore x is equal to 1.5 into sin theta. X equal to 1.5 into sin theta. But in this problem theta is not given. Theta is not given. Now we are going to determine the theta value. Now this is, I am going to take here right. Now this is theta. This is theta. This value we know because this is 1.5 meters and this is 4 meters, 1.5 meters. This value is equal to 4 minus 1.5. Okay, and this is 3 meters. Now take sin theta equal to opposite side 4 minus 1.5 equal to 2.5 divided by 3. Therefore, sin theta is equal to 0.8333. We have sin theta value. Now we are going to determine the h bar. H bar is equal to 1.5 plus x. That is equal to 1.5 plus x is nothing but 1.50 sin theta. Sin theta we have determined here, that is equal to 1.5 plus 1.5 into sin theta equal to 0.833. Therefore h bar is equal to this is the value, right? Now we are going to determine the total pressure. H bar is equal to 2.748 meters. Now we are going to determine the total pressure. Cp is equal to rho g a h bar. Rho is 1000 kg per meter cube. G is equal to 9.81 into a is equal to pi d is equal to 3 meters. Pi d square by 4 into h bar is 2.748 meters. Finally, total pressure is equal to 190621 newtons or 190.62 kilonewtons. Now, center of pressure is equal to ICG into sin square theta divided by AH bar plus H bar. Therefore, ICG is equal to, in case of circle, moment of inertia about the centroid, pi d power 4, that means 3.0, pi d power 4 by 64 into sin theta value we know that is equal to 0.833 square divided by a pi 3.0 pi d square by 4 into h bar. Already we have determined that is equal to 2.748 plus h bar is 2.748. Finally, center of pressure or h star is equal to 2.89 meters. Here also, this is the h star. H star is equal to 2.89 meters, so h bar is equal to 2.7 meters, so 2.74 meters. Therefore, the center of pressure is lies below the h bar, that is the distance between the center of the object to the free surface. Right? These are the problems related to the inclinedly immersed bodies in the liquid. Right? Compute the horizontal and vertical components of the total force acting on a curved surface AB, which is in the form of an quadrant of a circle, of radius 2 meters as shown in figure. This is also 2 meters, right? Okay. They want to determine the horizontal force and vertical force. What is horizontal force Fx and what is vertical force Fy? Right? Just I have derived in the last class horizontal force, that means Fx. The horizontal force Fx exerted by the water, the horizontal force or the Fx exerted by the water on the curved gate, that this is denoted by A, B. The horizontal force Fx exerted by water, the horizontal force Fx exerted by water on the curved plate is equal to the total pressure force, the total pressure force on the projected area of the curved surface. Total pressure force on the projected area of the curved surface on vertical plane. This is the projected area of the curved surface AB. The vertical plane of this curved surface is CB. CB is the vertical projection of the curved surface. Therefore, on the total pressure force on the projected area of the curved surface AB on the vertical plane. Therefore, total pressure force, I know, you know, already I have given formula, that is equal to rho G A H bar. What is rho? This is the water. This curved plate is inserted in the liquid is nothing but water. Rho is equal to 1000 kg per meter cube. G equal to 9.81 meter per second square, and area is equal to, what is the area? This is the depth. Width of this piece is given, taken unit. The width of the curved portion is unit, that means is 1 meter perpendicular to the plane of the paper. Therefore, area equal to 2 meters depth into width is equal to 1, this is equal to 2 meter square. And H bar is equal to, that is the distance between the center of the quadrant of the circle to the free surface. This is nothing but H bar. Therefore, H bar is equal to 1.5 plus 2 by 2. H bar equal to 1.5 plus 2 by 2. This is equal to 1.5 plus 1. That is equal to 2.5. Therefore, total pressure force on the projected area of the curved surface AB in the vertical plane is equal to Fx is equal to rho, that is equal to 1000. వస్తుంది కదండి ఇది? ఓకే, rho 1000 into 9.81 into A, that is equal to 2 meter square, into H bar equal to 2.5. Right? Therefore, Fx is equal to 49050 newtons. This is the horizontal force acting on the curved portion AB, that is on the plane surface CB. Right? This is the horizontal force. Next, vertical force. Vertical force FV. Vertical force is denoted by FV. Exerted by vertical force FV exerted by water on the curved surface. On the curved surface. That means Fy is equal to the weight of the fluid element. The weight of the fluid element on the curved surface up to the free surface. Weight of the water supported by AB. Weight of the water supported by AB up to the free surface. Weight of the water supported by AB up to the free surface. That means weight means mass density into volume. That is, mass density is nothing but rho G. Mass density into G is the weight. Weight is nothing but W is equal to rho G. That already I have given. Unit weight is equal to mass density into G. This is the weight into volume. Right now, this is equal to rho G. What is the volume? The volume of this area, depth is equal to 1.5 meters and width is equal to 2 meters, and perpendicular to the plane of paper, that is taken as 1. This is the volume of this area ACXY. XACY. The area is equal to 1.5 into 2. Volume is equal to into 1. taking per meter width, plus what is the volume of this one? The circle area is equal to pi r square. That is the formula for the determination of area of this circle. This is the quadrant, therefore divided by 4. Right? This is equal to, rho is equal to, this is the liquid mass density of water, that is equal to 1000 kg per meter cube, into G value 9.81, right? 1.5 into 2 into 1 plus pi. What is the radius? Radius is given, that is equal to 2 square divided by 4. Therefore, the force Fy, the force, vertical force acting on the curved surface AB, the vertical force Fy is equal to 60249.1 newtons. This is the vertical force. This is the horizontal force. Right? Thank you one and all. Thank you.